Today we worked on solving one-step inequalities, and hopefully as we reviewed this that you guys thought that they were super similar to solving one-step equations, okay? When we are working with a one-step inequality, the goal is still to get that variable all by itself, okay? So we're going to use all the same steps we did when we were solving one-step equations. The only difference now is we're not going to have one exact solution. We're going to have a solution set or a set of multiple solutions. Okay, so first one is we're going to look at our equation and we're going to determine what what inverse operation the inequality requires. Okay, we're going to perform that inverse operation to both sides, and then we're going to write our answer in the form variable, but instead of an equal sign, we're going to have the inequality symbol in the solution. So we talked about when we were graphing that the arrow followed the graph and the inequality sign if the variable is on the left. So we're always going to have our variable on the left, the inequality symbol in the middle, and the solution on the right. Okay, so let's just do a quick refresher since we're going to be graphing our solution sets. If we're graphing greater than, we're going to have an open circle with a line to the right. Okay, open circle, line to the right. If we're graphing less than, we're going to have an open circle with a line to the left, okay? Open circle, line to the left. If we're graphing greater than or equal to, we're going to have a closed circle with a line to the right, okay? Because it could be this value or anything greater. When we're graphing less than or equal to, we're going to have a closed circle and a line to the left. Okay, closed circle because it could be this number or anything less. Okay, so let's take a look at some examples. Now, when we were solving one-step equations, I had you guys draw a line through the equal sign. When I'm solving inequalities, I like to do a dotted line so I can still see what the inequality symbol is. Okay, however, we're still going to separate it with a line on the left so we know whatever we do on the left, we have to also do on the right. Okay, so on this one, we have an m plus 5. To cancel out our plus 5, we're going to use the inverse of subtraction. So we're going to subtract 5. Whatever we do on the left, we also have to come over here and do on the right. We have a plus 5 and a minus 5. So those are going to cancel, and we just have our m, which is exactly what we wanted. We wanted that variable all by itself. We're going to drop down our greater than sign, and then I have 3 minus 5. 3 minus 5 would give me a negative 2. So m is greater than negative 2 is our solution set. And now we're going to graph it. So on my number line, I'm going to mark negative 2. It is greater than, so I have an open circle. Since it's greater than, I'm going to have an arrow to the right. Okay, so there is my solution set. Now let's take a look at 1/2 w is less than 5. Okay, again, we've got our, I got my dotted line because I like dotted lines so I can see the inequality symbol, whatever you choose to do. So we have to ask ourselves what math operation is happening between the 1/2 and the w. Okay, we know 1/2 is a coefficient here and w is a variable, and that they're being multiplied together. So to cancel out multiplying by a half, we're going to divide by a half on both sides. Okay, whatever I do on the left, I have to come over here and do the exact same thing on the right. So on this side, we have a times by a half and a divide by a half. Those are opposites, so they're going to cancel out. And I have just my w here. I'm going to drop down my less than sign. And then on the other side, I have 5 divided by a half. Okay, now we can use our calculator for this. 5 divided by a half is going to give us 10. Okay, so our solution is w is less than 10. Okay, now we need to graph the solution set. So on our number line, we are going to plot our 10. We're going to have a less than, so it's an open circle. For less than, our line goes to the left. And there's our solution set. Not 10, but anything less. Okay, all right, down here we have 12r is greater than or equal to 48. Okay, so we're going to draw our line and separate our inequality. I know that a 12 right next to an r means to multiply. So to cancel out a multiply by 12, we're going to divide by 12. Whatever I do on the left, I have to also come over and do on the right. So I have a times by 12. I have a divide by 12. And those are opposite, so they're going to cancel each other out. And I'm left with just an R. I'm going to drop down my greater than or equal to sign. And then I'm going to divide. I've got 48 divided by 12, which gives me a 4. So my solution set for this is R is greater than or equal to 4. Now we need to put it on a graph. So I'm going to come down here on my graph. I'm going to plot 4. It is greater than or equal to, so I know I have a closed or a filled in circle. And it's greater than, so I have a line that goes to the right. Okay. All right. Last one we're going to look at all together. We're going to start by separating or splitting our inequality right down the middle. We have a y divided by 3. So to cancel out this divided by 3, we're going to use the inverse and multiply by 3. And whatever I do on the left, I've got to come over here and do the exact same thing on the right. So we're going to multiply by 3 over there too. I have a divide by 3 and I have a times by 3. And those are opposites. So they cancel each other out and I'm left with just y. Y is less than or equal to 3 times 3. And 3 times 3 gives me a 9. So my solution is y is less than 9. Now we're going to come down here and we're going to put it on our graph. So I'm going to plot my 9. I have a closed circle and a line to